That looks good. That looks good. That looks good. And
Oh. Hi, everybody. You know me, it's David again, and welcome back. Can I just get thumbs up in the teams there if you can hear me on the video? That'd be great. And then I'll actually start talking about relevant things other than if the audio is working. Thank you, Chris. So you might see me look a little farther to the right this time. My chat's farther away from me than I usually like it. so, and I'm blind, so I have to turn my head and actually look. So, Mr. Bean meme, yes. Last we left off, we were talking Fusion 360 and some CAD softwares, and I know that I got some emails about stuff, questions here and there. But did you guys have any questions about Fusion we could answer really quick, or CAD in general before we jump into the next topic? And I didn't see any name tags, so I didn't print any. So sorry. Did did you guys not get to it, or was it just like it's the weekend, we're busy, I'll do it later? Probably that one, I'm sure. All right, so I don't see any questions popping up. I do see that for some reason, we're down a couple of viewers on YouTube. Yeah, working on other projects. Me too, man. I'm busy getting a makerspace set up in the garage for my printers and my CNC. So we're starting that project now to move out. I do see we lost a few YouTube video viewers, so I might just hang on for a second to see if they reconnect. Kids as well. Yeah, life happens. Especially right now, you got to entertain everybody, right? So, um, all right, I see that viewer count going back up here. And yeah, so today we are going to be talking about slicers, remote control of printers, and any questions you guys might have along the way. So I'm going to throw the first little bit here to my good friend Greg, and he's going to take us through a few of the control mechanisms for 3D printers. So without further ado, here's Greg.
Hello, everybody. Hope everyone can hear me. We're trying something new with the sound today. So, thumbs up if you can hear me okay. I'm quiet. All right. Well, I'll see if I can talk a little louder. How's that? Is that better? All right. So the first thing I want to talk about is ways to interface with your printer. Pronterface is a great utility. When you set up Prusa, or you have an option during the setup to have Pronterface installed, you can separately go and download it. What it does is it allows you to connect to your printer board and be able to see what settings are on your printer, execute commands to level your printer, a number of things that you could, some of them you could do with your click wheel, but other ones you may want to actually use Pronterface to actually run it. Now I'm going to just fire up Pronterface here and I will show you what it looks like. And here we go. So when you fire up Pronterface, you have this little tiny area on the right hand side. And if you double or just click over here, you can drag this part larger. And this is your console window. This is where your communication with your printer is going to be. Now, I do believe I have to turn off my slicers here, at least Kira, because I don't think, there we go. So you'll need to know your COM port number. So when you connect to your computer, you can go to your device manager and whoops, not disk manager, sorry, device manager, live demo. Uh, and in the device manager, you can actually find what device you're plugged in with your printer. So if you have multiple printers, you can know which one it is. So we're connected on COM10. I'm connected to the printer, and if I do a 503, M503, sorry. This shows all of your settings in your firmware. Um, Depending on which printer you have and which firmware version you have, it may show you more or less settings. But this is where you can change different settings, your E-steps, so how much filament comes out of your extruder, your speeds, your acceleration, all are in here. So if you want to see what the settings are in your firmware, maybe someone said, oh, well, you need to adjust your E-steps because you're under extruding. Right here on line M92 here, this is where you would find that information on where you're at, and then you can execute the command to change any of those settings. So you can also home your printer settings here. If I hit home, my printer behind me starts to home all its x-axis. I can home everything. You can set your printer temperature. You can actually upload a file and print it from here, tethered to your computer. It's not really the recommended method of printing because for many reasons, your Windows could update. There's lots of reasons why you don't want to tether to your computer directly to print because there's so many things going on your computer that could interrupt your printing process that it could be problematic. So, but this is a good way to diagnose issues with your printer and get settings. If you want to change a setting, you would go M500. That writes your settings. If you get a BL Touch, you can adjust your offset to your nozzle height and whatnot with this console. I don't know if anyone have any questions about consoles, but we just wanted to show you this because when we get into Octoprint or some of the other pieces that David's going to show you, they have a console portion to them that you can utilize, and so this gives you another option. There's multiple ways to use your console to communicate with your printer and multiple reasons that you might want to also. Let me just go to here. Now, David, did I miss anything, or is there any other things that we should mention about the console?
Not really. The console is one of those things. As you start, you don't really dive into it a whole lot, but it's one of the places you always go as you progress in 3D printing to actually diagnose problems.
Yeah.
So when you start getting into like troubleshooting issues with your printer, it's not like you want to plug the SD card in and then try to just send one line of G code from the SD card. So that's why, and Greg mentioned it, it's a great interface if you do not have like a Raspberry Pi connected or anything like that. So
yeah, diagnostic is how
yeah.
it's mainly used, I'd say.
Yeah.
So,
and Pronterface has been around since the beginning of time.
yeah,
like it's old.
It is old, and a lot of other tools will have a console in it. Typically, your slicers out of the box don't have one. That's why Prusa supplies Pronterface in as an option to install when you're installing it. Kira does not have a console, which that'd be a nice, because it's always connected to your printer, be nice as an option. So I'm going to hand it back to you, David, and you can talk about the next part, and I'm going to answer the door.
Okay. So apparently Greg's answering the door. So here we go. So we are going to show you a little bit more about the printer control mechanisms. Now, thumbs up in the chat. Who has a Raspberry Pi? Let's see. Who has one? Who's used one? Who knows what they are? Everybody know what a Raspberry Pi is? Thumbs up, teddy bear, whatever you want to send in chat would be great. So we got printers don't come with the cable. Yeah, you are right, Andy. The printers do not come with the connection cable. So you'll have to find a mini, not the micro, so the mini USB cables, and those ones will connect to either your Raspberry Pi or your computer. But the next thing we're actually going to talk about here is a little bit of Raspberry Pi control interfaces. So when you look at the Raspberry Pi interfaces, there's two big ones. One's called Octoprint and one's called Astro Print. There's an older one out there called Repeatier server as well. We're not really going to mention that. Our printers don't use them very much anymore, and it's not as well maintained as the other two. So we're going to talk a little bit about Octoprint first, and then we're going to go into Astro Print. I will say that on our YouTube channel, on the 3D Make It, we've put out installation videos for Octoprint. So you're not going to see that live right now, but the installation for Octoprint and AstroPrint are all on our YouTube channel. So you guys, if it's something that you want to pursue, you can for sure follow those videos. I guess a little bit of the why we use Raspberry Pis as controllers before we show it would be the Raspberry Pi runs Linux, and the specific build of Linux is Raspbian for the Raspberry Pi, and it doesn't sleep. So the Raspberry Pi is always on, which means you don't run into those problems like a Windows update or anything like that you would with Pronterface. The other reason is 3D printing is full of data weak points. So the SD card that comes with your printer, although sufficient to start with, is probably the worst thing on the planet. So you probably want to go out and just buy like a SanDisk or Kingston micro SD card, like a class 10 or better, if you're going to stick with the SD card. But what the Raspberry Pi does is it lets you get out of the I'm stuck to plugging this SD card into the front, and you actually can get longevity out of your controller then, because what happens when you put that SD card in and out, you're going to zap it one time with static, right? That system, yeah, or you'll miss the hole, you'll drop the SD card, you'll mechanically break it. There's just so many things, and I'm not saying that you should completely walk away from the SD card, but what I am saying is the Raspberry Pi gives a solid control interface. So that's kind of why we introduced this as a topic. The other reason is remote control. I am forever printing outside of my printer room. Like, I'm not always sitting here, and I want something to print. So when we want that to happen, we do need some sort of remote control, which means, what if I have to cancel it? You can't cancel it on an SD card, even if you got a Wi-Fi camera sitting watching that print, and you see it screwing up, but you're at Walmart and you can't actually I need to stop this before bad things happen to my printer. So I'm going to toss it to Greg, and he's going to talk a little bit Octoprint with you, and then I'll do AstroPrint. So Greg, back at you.
All right. So I'm going to bring up our one of our printers. Just hold on a sec. All right. So you can see here we have a number of printers available here, and I'm bringing up the server. This is what we were streaming earlier. Just ignore the box in the corner. You're seeing it's it's a print job that's happening on one of our printers. Now, what's really nice about Octoprint is you can get various plugins to change the look of it. Your normal look, you've got a temperature control, so you can see your current temperatures. You get a nice graph to see if maybe your thermistor's bad. You can see it's very consistent across the board here. You get your print times. Again, always use a grain of salt with your print times. It might say that there's 11 hours left of printing, but it could be 15. It really depends on how accurate it's never 100% on those. You always have to add some time. Another nice thing is if you look on the left here, we've got various jobs that we've printed on this. The nice thing is if you have something you're going to print a lot, you can save it here and then repeatedly print it remotely without ever having to send it. And the other nice thing is I can just drag a sliced file. So let me see if I can grab one here. I had one earlier. Live demo, always wonderful. 3D objects right here. So I'm grabbing this and I can upload to the SD card, which isn't plugged in on this one. Or I can upload to the Pi, and then I just drag this, I let it go, and boom, it uploads it right here, ready to go. And then I can, right, yes, some will let you upload and some won't. So that's just you also can control your printer from here if you're diagnosing it. Let's say you're trying to get your filament extruding, it's hot and whatnot. You can adjust it here. If you want to speed it up, the little knob on the front for your flow rate, you can adjust it right here. We're at 100%, so you can crank it up if you want to. And here's what we were talking about. Here's our terminal. It's printing. It's sending through all of the G code. And you can see all the commands. These are all the move commands and extrude commands that it's doing, how much filament it's extruding. You can suppress temperature settings. This is where you would do your M500 to save your settings or change your settings. Again, you can do this without Pronterface. We're just through a web interface directly connected to the printer. This job, I can now hit cancel. It asks me, are you sure you want to cancel? So now if I hit cancel and I go to my control panel in a second here, it's going to stop and then I can home it. And there I go. I controlled my printer. I canceled the job and away we go. Now, obviously, you got to clear your print bed, and you have to be there to do that. But you do have a lot of nice settings here. Now, the other thing is this is very open. If I go click on the wrench up here, you can actually go into here, and there's quite a few different settings in here. This plugin manager is quite nice. There's a variety of plugins you can get to do various things depending on what you want to do. There is an Astro Print plugin, which I think David might touch on a little later. But there's a variety of different plugins. I've changed the look of this one. If I go to the dashboard here, regular Octoprint doesn't look this way, but here we are. We have we can see our temperatures are cooling down. I can pause, cancel right from the screen. It just makes it look a little fancier. Now, keep in mind, if you have a Pi Zero, you probably don't want to run too many plugins because there's not a lot of power on a Pi Zero. But if you have a Pi 3B or a Plus or a 4, you should be able to run pretty much anything you want. And having the camera to monitor your jobs, see if your print didn't stick to the bed or whatever, so you can cancel it, very beneficial. So I think I'm going to hand it back to David now. Uh,
Hi, it's me, David again. So Octoprint is definitely one of those options for remote control. It does have a few uh, little tiny quirks in it, but yeah, like open source, it's free, and you can have as many as you want running. Meaning, you don't have to create an account on their website. But Octoprint in general, unless you're running like a Pi 4, is a one-to-one instance. So like one printer, one Raspberry Pi. So for every printer that I have one Raspberry Pi. Um, is it transfer rate affected over Wi-Fi? So I guess yes and no. Transfer rate to the printer. So if you're transferring, like Greg had shown, to just the just to the Raspberry Pi send here. So if you're just dropping this into here, you're fine. The transfer rate, you'll never really notice a slowdown to the controller. If you use the upload to SD feature, the slowdown actually occurs because now you're sending the file to the control board, and then you're sending it to the print, and then the printer is sending it to the SD card. So that's why that slows down. So that's why we recommend going right to the Raspberry Pi. Also, in my, I don't know, 4 years of using Raspberry Pis as controllers, I've only had one SD card go bad in my Raspberry Pis. But I've had two cook themselves in my printers before I went to Raspberry Pis. So it gives a better base if you're just uploading the files to the printer. The next thing we're going to talk about, now that we've shown you Octoprint, is a utility called Astro Print. So Octoprint is a Raspberry Pi base, and Astro Print is a Raspberry Pi based software. So you can kind of see here the difference. So this screen is your home dashboard on your local Raspberry Pi of AstroBox. So you go to the IP address, you log in. I'm not going to show you the log on screen because I'm sure we've all seen a username and password prompt before. But a key difference between the username and password on the AstroBox versus the Raspberry Pi is the AstroBox login is secured to your Astro Print account, which you have to have to run an AstroBox. AstroBox are similar to Octoprints in the fact that they're one-to-one to your printer, but AstroBox and Astro Print have this cool cloud feature available. So one thing when we're looking at an Octoprint instance is this is all well and fine. I mean, it's kind of antiquated at the front end for visualization, but for you to get access to this outside your network, you're going to either have to allow a third-party app access to it to transmit it to your phones or your computers, or you'll have to have firewall level access to port forward and do some other tricks on the network side of things to get everything happy. And if you're using them at school right now, unfortunately, the answer is no, we won't port forward Octoprint. There's too many. Too many of them that would probably need it, and B, the security stuff involved is just not worth it. So step in Astro Print. You can see here that similar to our Octoprint instance, we have our control panel. We have a file upload. This is on my local one still, and I'm going to show you two dashboards. So this is the local one. I can upload. I have a file manager. There is no default file manager for the Octoprint instance. So all the files come in here, but if you wanted to move this file into that calibration folder, it just highlights it. Now that being said, like Greg showed, there is a file manager plugin, but it's still kind of janky in there. It's not the nicest of experience, but if you come into this file manager, it would load your files and show you, and you can move it back and forth from the cloud or back into the internal external environment of your controller. So that's one cool feature, but you can see that they've done more design work. It's flashy on the front. One thing to note is AstroBox is actually a fork, and I'm not talking about like the dinner fork. It's actually a fork of Octoprint. So it's using a lot of the same back-end code to drive that utility, but it's giving it a nice shiny front. Print queue, we're going to talk about that one in a second, but the utilities is the same. So utilities let you move your printer. So my printer says it's not connected because I just turned it on. So if I click my little red printer, it'll flash and connect, and there's all my controls. And you can see it's very similar now to the Octoprint. So I'll just go back, and there's the control tab. And you can see it's similar. They just kind of flash it up a bit. It looks better. They use more design styles, and that's partly because Octoprint is one person. Her name is what? Gina, I think. But like she does Octoprint. That's all she does. It's one person, and the Astro Print team is a team. So they have developers and front-end designers that can put that extra flash on it. We can click through and we can view the camera locally, the settings locally, and the terminal locally. So all of this is very similar at this point. So nothing's really changed. The setup is almost the same actually for the Astro Print and the Octoprint boxes. But here's where it gets different. Okay, this is the magic sauce that makes Astro Print amazing. And we're going to talk about it a few times today. But on this tab, I've gone from my local IP address to my Astro Print account. So if you go to astroprint.com, if you do not have an account, you have to create one. The button will be up there. You can create one. And you can have up to 2 printers for free on their free platform. And then after that, if you wanted up to, I think it's 10, you have to pay $15 American a month. So that's very like Amazon-esque. You get to subscribe to a service. But that being said, there are some really cool features in the cloud. For one, you'll see most of the buttons actually exist in both places. So we can monitor, we can upload files to our printer from here. So we don't have to be on the printer anymore. And then we can send jobs remotely to our printer. The Astro Print team has an Astro Print app for iOS and Android, whereas Octoprint, there's no actual app for it, but people have developed apps for it. So again, it's third-party developers using that open source platform, and there's nothing wrong with that. I've been on a few open source teams myself, and you know that environment can provide a lot of flex. But one thing that you can do is you can monitor your printer from the cloud. So I don't have to be on my local network. It tells me it's ready to go. It's online. It says red PLA, but you can actually set whatever you have loaded if you wanted to get granular about it, and it would change the PLA color so you remember. You can launch the local instance. So if you are at home and you want that local controller, you can do it right from this monitor tab. And again, the camera. So the camera is one of those things that you can actually tune in. You can switch to video, and then the space monkey comes up, the vampire space monkey, and you'll get a live video feed of your Astro box. Now, Octoprint has this plugin, so many of those features are shared, but there are sometimes communication issues between the plugin and the Octoprint where you won't get the video feed like you will here. So you can see it does take a while to actually spin up the video, but it will start going eventually. And then you can see your printer temperature underneath in the monitor tab. So right now it's a balmy 19 degrees in my basement, and they're not on. They're a 000. And there's my CR10S sitting there ready to print. I can verify that my print bed is clear. So if I wanted to send a job, I could. That's in a nutshell the features of Astro Print. Now, Astro Print works across firewalls because it's all cloud driven, so you just need that account. If we have some time, I'll show you a bit more about these beta ones, but it's important to note that Astro Print actually uses Kira slicing engine in the cloud, which means you can sit on your couch with your iPad or a Chromebook or not Windows device or Windows laptop, right? And you can actually slice it in it. And when we get to the slicing section, I'll show you a little tiny bit about how the slicer works in Astro Print, because it's a very powerful tool, and I go into like a whole lot more detail than in our 3D Make It channel than I will today, just on some of those features. But the other cool thing with Astro Print itself is integration. So you actually get integrated to Thingiverse, which I'm sure you've all visited now and tried to use their awesome website. My Mini Factory is also available. And then they do actually have some cloud services. So there's a few designers up there, as well as a cloud printer. So you could print to another cloud print if you wanted. So Astro Print is a little more closed source than Octoprint. It's a little more user-friendly to get going. But if you are the kind of person that likes to tinker with your computer software, we can, if you like to tinker, get under the hood, that's your shtick. Octoprint's going to be the choice for you. So that's okay. Let me look at the question list. Can you cancel a job remotely? Yes, Aaron, you can. If you are using the Astro Print Astro Box, so you have Astro Box locally, and you're monitoring your print job in the Monitor tab, you can come in here, and when you're in the control and it's printing, there is actually a button that will say cancel when it's printing. Now, the other way you can also cancel, if you've hit canceled and it's not quite canceling, you can actually disconnect the Astro Box, and that will basically simulate pulling the plug, the USB plug out of the Pi, which will stop the print job in its tracks. Wait a few seconds, reconnect, and that'll be this button here. It'll say reconnect, and then you can move the print head up and wait for the cooldown to happen. But yes, if you have a job printing, you can cancel them with Astro Print just as you can with Octoprint. Again, you do get a little more control-ish, shall we say, when you're on the local box. When it comes to complete control of the printer. But for remote control, you're sending that print job from wherever you happen to be, school or home or the grocery store, or it's 2 a.m. and you have that urge to print something. You can send it, you can stop it. So Astrobox, is a very viable source of printing control. The terminal is almost exactly the same as when we talked Octoprint. So if I issue M503, it'll throw my settings up on the screen, and you might be thinking, well, how do we know what these G codes are? Don't worry, we're going to show you. And we'll explain why they're important. And you don't have to memorize them all. You don't have to memorize any of them, but we'll show you exactly where you can find what they mean and kind of the important ones to look at inside the terminal window here. Andy is asking, are the cameras connected? And Aaron answered the question. Boom. Yes, they are. Logitech cameras all work very well with the Raspberry Pi. You don't have to go out and buy like the $200 stream camera. So you can use any camera. Like I think the budget camera I got on my Predator was about $20 from London Drugs. It's a Logitech. You don't need to worry about like getting 1080p per se. 720 is just fine, so you can cheap out a bit when you buy those cameras. The other ones that do work, now take this into consideration, is the Raspberry Pi cameras. The Raspberry Pi cameras work very, very well with Octoprint. They're hit and miss in Astro Print. You can make them work, but there's a few settings to go into in the local box. So if you're in your local Astro box and you're doing your camera settings, it's all in the settings panel here. And then when you go down to your camera, you can actually change formats and it will auto detect what camera is plugged in, and you can set the resolution. If you have to mount your camera upside down for some reason or on its side, you can rotate it in there. So you do get easier access to those features, because on an Octoprint setup, all of that's through like an SSH terminal. And yeah, you have to know a little bit of Linux to edit the text files and go through. They have laid it out nicely. It's all in one place, but you have to kind of get into the programming bit like this much. It's not even programming. I would say it's reading and entering some text. So that's Astro Print in a nutshell. Like I said, we do have some videos on our 3D install, and I'll go through some of these beta settings in a bit. We'll come back to it when we talk slicers, but I think that is probably the two best printer controllers out there right now. Like I said, there is a few others, but they're more closed source. So if you have like a niche printer that's not an Ender 3, one of my printers is it's called an SX4, and when I got that printer, it's not by a standard manufacturer, which means I had to make a custom printer. And it was possible to do that just because we had control in Octoprint. Now you can do the same thing in Astro. It's just a little harder. Yeah. So does that make sense, guys? That's kind of the why and the two control mechanisms for printers. Who's going to run out and buy a Raspberry Pi right now?
And Andy has a really good point. It's tough right now with the situation to find cameras. So
it is.
So
Amazon still has a plethora.
Yeah. So yeah.
Yeah, you have to. Yay! Greg Fisher says Raspberry Pi. Andy says Raspberry Pi. Don't hesitate. Do it. It's one of the best things you will do for your 3D printing experience. It smoothes the whole thing right out. It makes it easy to send the files to the printer, and we will show you a little bit about that when we jump into the Kira side of things. So I'm just going to show you a little tiny bit of voodoo magic here. Well, it's not voodoo magic, but I'm going to show you just where you can actually go to get those fancy G-code commands we were sending. So if you go to Marlin firmware, G-code commands. So that's all you got to type. Marlin firmware G-code. And you hit enter. And you click the first link. It takes you to this huge library. And I don't know about like Greg. I might know about 13 of these commands off the top of my head. They're useful, but you don't have to know all of them. And the ones that we were using, is bookmark this page. So like the ones we use a lot will come down to some PID auto tuning functions, and we talk about what PID auto tuning is, but basically, you remember that nice flat line we saw in our Octoprint temperature graph? That's because the hot end is tuned to receive those electrical impulses, and that's all set up by using this PID auto tune. And again, that's not something we're going to dive right into, but we do have videos on it on our 3D Make It channel. And we are more than happy to make more videos for you. If something is a bit confusing, you can just request or talk to us, and we will definitely hook you up with an answer. The ones we were using, these are the most important ones. This group in the M500s right here. Oh, that's not pretty. I was hoping it was going to like circle it nice. But basically M501, M502, M503, and M500. The one that you'll use the most is probably M503, and that just displays your printer settings. So we did that in our Astro box here, and that gave us all of these printer settings. So you can see here, there's like M200, D1.75. Well, what is that? We can pop right back in here, and it tells us that's actually the diameter of our filament. So you can use this as a spreadsheet chart, I guess, to go back and forth between your settings to find out what they mean. But M503 shows your settings, and depending on if you've changed anything in here, and you can change it through the terminal, you can alter your settings, that you can save them with M500, and you can even go back if you've messed up a bit with M501. So we're not going to dive too deep into all of this programming stuff right now, but I do want you to be aware that if you do need to see a setting in your printer, like if you ask Greg or I a question, and or Fish or one of us, and you say, hey, for some reason we're under extruding, right? Or hey, for some reason my printer is not holding temperature, we might throw back at you, well, what does your M503 say? And this is how you run it. You run it through the terminal, and it will get you the best help and the fastest answer.
It's
so
it's
like
definitely helpful when you have someone helping you diagnose a problem. If you do eventually get, let's say, a BL Touch for your printer, you're going to use the M851 command. That one adjusts the offset height between the probe, your nozzle, and your print bed in relative to the probe, so that you can get your first layer nice and tight to the bed and whatnot. I know in the past we've had a few people say, oh, my bed's warped. All beds are warped. Let's just put it out there. If you have a aluminum print bed, they're not super flat. They're flat, but they're not super flat. So getting it really level and really squishy, if you have really, this technical term, squishy, really helps on those ones, and having a nice level surface. And when we say level, we mean you're parallel to the gantry. So it could be like this.
Tram.
Yeah, it's trammed, and your gantry and your bed are parallel to each other. So everyone calls it leveling, but it's actually tramming it, and that's a good point. But you don't level it with a spirit level, because that's irrelevant. Because that won't tell you that your gantry up at the top that your print head runs on is parallel with your printer. So those are little things. Switching from the magnetic bed to, let's say, a glass bed definitely improves that, but you still need a really good level to get your prints sticking, even to a glass bed. And there's hairsprays and other additives you can do to improve your adhesion to the bed. I personally don't like glue stick. I don't know about David.
I use glue stick when I print PETG, so I don't tear chunks of glass off my printer.
Certain materials, if you're just doing PLA, then hairspray is good enough. But other materials, you want to change up what you do. So
yeah, and like the Micro Swiss hot end kits, I think they're still available for now, but I know that they are having a shortage of those too.
They're sold out at schools.
Yeah. So, and even on their website right now, because I think they're one of the ones that got hit, unfortunately, and their little factory got shut down for a while there. So, the G code that you use for that's all up there. Use the code Zelky10 for a discount. I can't verify that, but if you guys want to try it, do it for sure. When you're buying all metal hot end stuff, if there is a branded all metal hot end, generally speaking, go for that branded one. The off brand ones from like AliExpress sometimes are hit miss. Yeah. So I'm gonna jump into our slideshow here. And I'm just going to show this lovely slide that I took so much time building for all you wonderful people. I'm even going to maybe like hit it present here. And whoa. All right. It went to the first slide. Sorry. We're just going to click a bunch. So we've talked about all of this stuff except this page. Now, I'm going to ask the question in the chat. But how many people have used Prusa? We'll get a thumbs up, and how many people are using Kira? We'll get the panda bear emoji. So let's see, thumbs up for Prusa, Panda Bear for Kira. So I'm just curious to see where our users are at right now. So if you've used either of these, Panda. Oh, well, it's not Panda, that's Bear, but Bear's good enough. Bear or Panda Bear. So Andy makes a good point. I love it, Kurt. I love it. So Andy just asked about, and I'll mention it. He says, I have to replace my hot end. Well, no, you don't have to. But if you're going to print other materials other than basically PLA or low temperature PETG, your hot end is not sufficient enough to go above 235 degrees. After that, it'll start degrading, and that's the point of an all metal hot end, to replace that PTFE tube that goes all the way down. And I know Kurt is printing some hotter stuff. So hotter things include PETG, ABS, nylon, all that stuff on that red chart.
Sorry.
Oh no, you're
Sorry.
good. You're good.
I just also want to remind people that if you do change to an all metal hot end or something that you can print these other materials, please remember that you shouldn't print the like ABS or some of these other materials around children or pets and whatnot. You want it in like a garage, some ventilated area. You do not want it in a classroom. You do not, unless you have an older science room with a hood vent that you can put your printer in and suck the air out, because the off-gassing is toxic. So just be aware of that. I know David has a really nice, I think we had a slide on the previous workshop that kind of lists out the green, yellow, and red. If you went to the first workshop, it's available. I think it might be in our folder.
It's if it's not there, I'll put it there.
We'll put it in the folder just so you guys are aware that you they are trickier to print. So even though you have an all metal hot end and let's say you want to print ABS or nylon because you want something super strong, you will have to go through a learning curve for those materials, figuring out temperature, figuring out retraction and whatnot, and we'll talk about those things when we get into the slicers. But there will be a bit of a learning curve and trial and error to get your first prints perfect. So just
so there's a few other points that were made in the comments here. We'll just touch on those before we move on. Really good conversation today, guys. So that's awesome. Our resident Greg Fisher had said, what about a ruby nozzle? So the ruby nozzle is for when you are printing abrasive materials. So your fills, your nylons, they tend to wear a nozzle quite quickly. Like brass is very, very soft. So putting those abrasives through it, orifice, and it becomes a it becomes a basically circle orifice, and the nozzle becomes useless, or it becomes bigger than you think. Kurt says, so is this why I've had so many headaches lately? Actually, Kurt, could be. All metal hot ends are a different beast. The PTFE stuff that come with the ender, so that one that goes all the way down to the end, is actually a lot easier for beginners and actually like seasoned veterans to use, because that PTFE is a little more forgiving, where the all metal is such a, it's there, it's metal. If you're not retracting fast enough, it can actually kind of jam and pull. If you're not putting it back in fast enough, it can jam and pull. So there's definitely advantages to the all metal, and actually I think I've got all metal on all my printers except my Predator. So like I love it. But I'm also printing high temp PETG. But I want to touch just on one thing too. When Greg was saying like we shouldn't print certain materials, just so you understand, PTFE is Teflon, and when Teflon, so PTFE is that white tube. So let's say we're printing ABS. Don't print ABS. But let's say we're printing ABS, and we actually get our hot end up to that 260, 250 degree heat. There's two things that happen. One, when ABS gets too hot and starts burning, it releases styrene gas, which will kill you eventually, slowly, with cancer. So don't, that's why we say, use an enclosure for that stuff. The other thing is, once you start heating Teflon, it creates a neurotoxin, which is even worse than the styrene gas short term. So it will kill small pets and
children.
Children will have ill effects. So you want a nice ventilated area if you're going to go high temp with ABS and that stuff, even with the proper materials, because there are PTFE tubes that have been treated, like Capricorn and other things, that can print a little warmer, but in the end it's still Teflon, so it will off gas. I did find here, I'm just going to throw up that slide really quick, Greg, for those temperature things. So here's our chart, and where's the one? Can I make it big? I always forget where it is. It's okay. I'm not going to make it big, but I'll pop this into our folder, guys, so we have a reference. So the stuff in the green, PLA flexible, you can actually print on a stock ender. PETG, yeah, right out of the box. PETG and metal fill and wood fill you can do, but they are either a low temp for PETG, or you have to change the nozzle for your wood and metal fill. And that means you're going to want a bigger nozzle, so probably a 0.6 instead of the 0.4. So that's kind. No worries. That's kind of what this chart is for. When we say nope on the chart, you will see nope. We're just talking stock. So if you go up to that all metal hot end, you need an enclosure. It helps with warping. Nylon is very hygroscopic, which means if it absorbs water, you can't print it anymore. It just pops and fizz, and that's it. So without further ado, if you don't have any questions on that stuff.
I have one more thing to throw in there. If you do have to change your nozzle out and whatnot, I believe we have a couple of videos on how to do that, but just quick tip, when you're changing your nozzle, you have to heat up your hot end.
Do it hot,
because you've got two disparate metals, like two different metals, right? And so you need to heat it up to get some expansion and then be able to then twist it off. Now, if you don't do that, you will snap your nozzle in the heat break, and then you're going to have trouble. So always heat it when you're removing it. Now, you can torque it up a bit when it's cool to when you're putting it back together. But then what you need to do is remember to heat up your hot end and do the last tightening while it's warm. Now, you don't have to be, the Hulk. This is a brass nozzle. Brass is a very weak substance, unless you have an all-metal nozzle. But either way, you don't need a ton of force to get it to be tight and not leak. You just need to get it tight and then heat it up and give it a nice little, like, eighth quarter of a turn kind of thing to snug it up. So just remember that, because I know a few people have had issues, and a lot of times people don't realize you need it warm to do that work. And again, feel free to use our website as a resource. There's lots of other guides online on how to do that. So.
Yeah. The most common mistake, and I've done this two times. I tried to print metal fill. That is experimental filament. Actually, it's like a beta filament, and I knew it didn't work because I wrecked my one hot end and had to switch it. But I'm like, I'm just gonna try it again. I'm gonna try it again, and yeah, same result. So, yeah, use definitely, and it happens. You can replace the stock hot end on an ender for under $30. So just keep that in mind. Whereas the kits from Micro Swiss are like About 80. And it's important to note that the Micro Swiss kit nozzle is not like a hardened steel nozzle. It's actually still brass. They just do a stainless coating on the outside that's patented.
And
So
nozzles aren't expensive. If you're just replacing your
no,
nozzle, a lot of times you
yeah,
can get a package of like 5 for like $10 or less.
oh yeah,
Sometimes, I mean, you can get really fancy ones for $25 a piece, but honestly,
or a ruby one,
or ruby ones for 80, $90 or
130
130
Canadian.
depending on where you go. But a typical nozzle, I have like a few dozen of them kicking around because if mine wears or breaks or whatever, I can just switch it out. So don't freak out if like the base parts, the nozzles, the heater cartridges, the thermistors that you do your temperature, those are consumables. They do wear out. They're easy to replace, and they're not expensive.
No, I paid $12 for my pack of
There you
40
go.
from Mech Solution, and those are stainless steel to answer Kurt's question. So, and then I have another, I think 30 of the brass ones just for general use.
Yeah.
The ruby one looks really cool, and it does have uses if you're using like the more extruder and stuff that pushes that volume through faster. The ruby nozzle is perfect, but on a stock ender extruder, you're not pushing that.
I don't know
So
too many people who actually use those nozzles. Like you need to be doing high volume of like nylon or metal fill or carbon fiber filaments, and I mean high volume, like printing 24/7 to really justify it.
yeah,
Yeah, and I
yep.
think we're going
So
to slicers next, right?
we totally are. So Gray's gonna take us into the world.
All right. So I think we had a lot of people say they had pandas, right? I think pandas was Kira. Okay, so here is Kira, and we're just going to go over a few of the basic interfaces. Everyone's kind of played around with it a bit. Most people are not in they don't have the fancy settings. They might just have the basic settings rather than the advanced stuff. But I want to just make sure everyone's familiar with the interface. If you go up to settings and configure visibility, I know we talked about this a bit, but on the right hand side over here, you can see it has basic, advanced, and expert, and all. So depending on what you want to do, I think out of the box it comes up at basic. So if we go to basic here, we have a lot less options. And I know David in the last one, I think pointed out, you hit the little gear and you can turn on additional features under each section. So I just wanted to, or Fish did, I just want to point out that both this one and Prusa, when David gets there, have these settings. So if you're not comfortable seeing everything and you get overwhelmed, you can go to basic and keep it simple so that you're not seeing settings that maybe could get you into trouble. But if you are like David, I always tease him, I call him Clicky McClickers, because he likes clicking through every setting, and that is a benefit to him because he finds stuff in here that no one knows about in right away. So once you kind of delve in, you can go all and you get a lot more settings. Another thing that we wanted to talk about is the marketplace. So if you click on marketplace up at the left at the top, or right at the top here, it's a little slow. Their marketplace is a little slow to load, but once it loads, there are a number of plugins that will give you more functionality. Come on, there we are. In your slicer. One thing that Kira doesn't do, and I think we mentioned this last time, is 3D Builder is really good at repairing models that are damaged. And if you just take a model, throw it into Kira, you won't know if it's damaged until you try to print it, and even then you might not know why it didn't print right. If you download them and install these mesh tools, you'll get a nice little help on the model. It'll check the model as you bring it in to tell you if it's bad or not. Now, there are a few other tools that I like. I don't like this automatic slicing. I know some people recommend it. If you have, let's say, an older printer that you found, like a MakerBot or whatnot, you can add a plugin so that you can slice it in the old style of files. It doesn't understand G code properly, so you can do the X3G format. I like the sidebar tools. There's a few other ones. Printer settings. So you've got your printer settings where you can go in advanced, but if you want them just in the side menu, you can add them. So there's a few things. So I'm just going to quit this because I've added the mesh tools. And I'm going to just bring up the mesh tools, and then I will bring in a model that we have chosen for today to do some printing. If anyone has been watching any amount of videos now that we've been in quarantine, some of you may have Disney Plus and been watching the Mandalorian. Well, we're gonna slice his helmet. So sorry.
That's my face.
I'm just waiting. Kira takes a long time to load, so I'll just switch to us for a moment while it loads. And
we're back.
And it's still opening here. It's nice and fast.
Yeah.
Oh, there we go. There we go. So I have some errors. Please ignore those errors. Those are just because I imported some stuff. Now I'm going to grab the helmet and I'm going to drag it and drop it in here. This helmet is too big for the build plate, obviously, because it's huge. So we are going to, look at this. The helmet has some errors. Now you can turn on this X-ray view. I couldn't see the errors myself. Yeah. So there's a hole in the back of the mask. Now what I'm going to do is I'm going to turn off I'm going to go back to layer view. Oops. I don't really want layer view, but whatever. I need to, first of all, scale this because it's not even going to fit on our build plate. So we'll just go 75%, and then we will center it on the build plate. And now we need to repair this. So if we go up to mesh tools here, you can do fix model, and it'll process and try. It takes a little while to do, but it will now repair and look for the open holes that are leaks in the model, so that it'll be able to actually slice it and prepare your model for print. So that's a really good one to add on. This is going to take a little while to do. I'm going to switch back to David and I. So while it's fixing that, do you have anything to say about the mesh tools in Kira at all, or?
Yeah, and it's that they mostly don't work usually. So when you're using the plugin, like it's there, it's okay. It will fix small errors, but I happen to know that this model is very, very damaged. And when we load it in, like when you first started, it didn't look like it. But this model actually has several errors. So Kira will chug away at it for a bit, but I mean, once you hit slice, it will look okay. So if you didn't have those tools installed, it'll look like it'll print fine, but it won't be watertight for one, which isn't a big deal because probably not going to put water in this one, but that means that it might cause an irrational movement on your gantry, so it can actually jerk and break your printer.
Well, or knock your model off the build plate. So then
Yep.
you now have maybe had 25 hours into a print, and now it just got knocked off. That's not a great thing to have happen. So
No.
just be aware of that and whatnot. And then let's see. I don't know if it's done. All right. So yeah, it's still chugging away here. Yeah.
Kira, I tell
It's
you,
it's when you're doing
it's a
some of the
thing.
plugins or some of the other settings, slicing at if you have a high resolution monitor and you slice in Kira, it takes forever. But if you dump the resolution down to something low, it actually goes not too bad.
Chugged along. Yeah.
Prusa Slicer is a little bit different. It doesn't seem to have that issue, so which is nice. My Kira is not responding right now, so I don't know. Do we want to continue with Kira, or do you want to go right into? Oh no, it
Let's
just
just
it
did it do
yeah, it
it?
came back. All right, so it's fine. So I'm gonna hit slice here. They can. So I'm just gonna check the mesh again. So it's still not watertight. So it still didn't repair it properly. So that's where you would have to take it into another tool. So now I know David's going to be showing another slicer, but if you bring up 3D Builder and throw the model in that, uh, it will probably repair it pretty well. And then then you'd resave the STL, and then you could bring it back into here, and it should be watertight at that point, and you shouldn't have any problems printing. Now, if you look at this, it's not going to print very well because it's floating in midair. So there are a number of ways to do supports. I think we talked a little bit about supports previously, but one thing you could do is just check off generate support. Now, everywhere will be everywhere. It'll be under the model. It'll be if there's a detail on the model, and if we were to reslice it with everywhere, you're going to have a lot of extra material. And your printing time will probably go skyrocket up here. And I think it'll show it right here. I'll just give it a sec to finish slicing. So, and this isn't necessarily a bad way of doing supports, but it's really model dependent. Some models, everywhere works fine. Typically, I don't choose everywhere. I'll do touching build plate. So touching build plate, if you have some details on the upper part of your model, it's not going to try to generate supports to hold a little tiny piece that's sticking out that your printer is capable of printing, but it thinks it's not, so it wants to support it. So keep that in mind. Everywhere is normally you're now printing one solid piece of plastic that you're never going to put it on your head as a helmet. I'd have to say it's still slicing, so I'm going to bring David up. And so, wouldn't you agree that everywhere is kind of hit or miss depending on the type of model you do?
Yeah, and every model has its different support strategies, and helmets are a special case
Yeah.
because they have that giant gap in the middle, and generally speaking, they're not flush around here, right? They have an angle, so finding a perfect way to lay it on the build plate isn't always possible. We talked about tree supports a little bit actually when we did our build this time, But
it's done
thumbs up
slicing.
if anybody wants to see that in the chat. So if you want to see a quick tree support,
So, well, I'll
how we
show the
would do it.
difference because here it's done slicing. I'm going to go back to the demo for a
Oh,
second. So, here is the helmet again, and I'm just going to turn it around, and you see it's got some weird supports on the ears, and whatnot. And if I slide down here, you can see it's got a whole bunch of support in the middle and whatnot. So we may want to switch it up and do tree support because you're going to use a lot less material. I'm going to switch back to David for a second because someone's knocking at the...
all right. It's all good. So, I mean, that's tree support is a strategy that exists in Kira, and it also uses some other stuff. In Idea Maker has tree supports as well, and FlashForge. But I think we're gonna shift gears from supports a little bit, and we'll wait. It'll take the tree support a second to slice anyway, and I'm gonna take you on a tour of Prusa Slicer and answer Aaron's question, other than a yes. So we'll wait. We'll answer Aaron's question about infill in like 2 minutes. I just gonna see. Did we, Greg? Did we get that sliced? Is it? Yeah. Okay. So Aaron, infill question. Now this is gonna get a little bit weird. So follow me down the rabbit hole. We're not gonna use the endo helmet for it though. Did it finish, Greg? Your tree support? Okay, when it's sliced, be the interrupting panda, and then we'll switch back. All right. I'm gonna slice a random model that's not called Baby Yoda. We didn't mean to make this a themed Star Wars Day per se, but it's turning into that. Yeah. Here we go down the rabbit hole. So, Baby Yoda. We have little Baby Yoda, and we can see that it's not manifold. That's fine. We know the mesh tools don't work. So if we zoom in on Baby Yoda, there's a few things we notice about Baby Yoda. One, his core is pretty round, right? So if I look from the top down, I don't really need a lot of support up the side of Baby Yoda. I will need, or infill I should say, sorry. I will need supports supporting his fingers, and I will need supports supporting his ears, right? And you can see those red lines everywhere, and that's support stuff. But let's talk infill for a second. So if we go down and we open our drop-down menu, and again, if you're not seeing this menu, it's because you're just looking at the recommended settings at the bottom. So if you see this menu, what we really want to play with is this custom one, and it'll bring up those options, and Greg showed us how to show them all. But if we come in here, one of the first things you can actually do, even before you get to infill support, like manipulation, is you can come down into your infill settings here, and you can change the support overhang of your infills. So let's just find that settings here. Infill density 10%, qubit subdivision is good. It's good, it's good, it's good. Infill overlap, wipe distance. Am I missing it? Infill support. Click. So you want to make sure infill support is on. Overhang angle. Since it's infill on the inside of the model, you can usually get away with changing this. So on my ender, and Greg might have something to say about it that I'm doing it too fast again, but that's okay. I always go 65 on my infill because if the infill does fall inside the model, it's still in the model. There's a really weird infill that we can show you as well in a second, but if we change that to 65, so let's just turn it off. I'm going to hit slice. We're going to wait for a second. Since I'm not doing anything too weird, we should slice relatively quickly on our Baby Yoda. And then I'll show you what the infill looks like with cubic subdivision, just infill inside. And then we'll do that. And while that one's chugging away, I'm going to talk a little bit about installing Prusa Slicer. Unless, Greg, are we finished slicing yet? We are not finished slicing yet, so that's fine. Prusa Slicer when you install Prusa Slicer, you're going to get Prusa Slicer. I sent the link out for Prusa Slicer. So double click the installer. It works on other platforms other than Windows, but I'm just going to show you a few gotchas. So Prusa Slicer has the installer is fairly straightforward. You click OK and yes a bunch. When you get to this screen though, on this installation, you want Prusa Slicer 2. You want the utilities. You do not need anything else except Pronterface at the bottom. So make sure that you check the very bottom Pronterface, Prusa Slicer 2, and utilities, and then click next, and then click next, and then click install. I already have it, so I don't need to click install. All right, so just to go back to be sure one more time, when you run the installer for Prusa, install Prusa 2.2, that's the first one, the utilities, which is the third one, and Pronterface. Unless you happen to own a Prusa, in which case you can pick the test objects for the Prusa specific machines, but we are not talking that right now. So that's how you install it. The only real gotcha is the Pronterface at the bottom. Make sure that you click that, and it's fairly fast and lightweight to open. So I'll show you a bit more about that in a second, but Baby Yoda is done. So let's click a preview on our Baby Yoda, and it will process our layers. And I'm going to change this to, so I'm clicking the middle bar here, and then I'm changing this to line type. And what that does is you can see everything about your model. So it tells you that the red lines are actually the shell. So that's the outside shell, the very last perimeter it prints. So in slicers, wall, shell, and perimeters mean the same thing. So if you're wondering, why don't I see shell and this guy keeps talking about perimeters? They're all the same. So you can have wall line count, shell line count, perimeters. Now, when you look at Baby Yoda, it'll be terrifying because we're going to take his head out. Oh no! All right, and you can see here, I'm about halfway down the model, and all of this orange is the infill, okay? So that's what the slicer at 10% infill will add into our model. It's important to note and remember that the strength of a model comes from the perimeters, the wall line count. So if we look in our slicer and we go shell, and then I can go wall thickness. So this is printing at 2 wall thicks right now, which is okay. On a model like Baby Yoda, if I was really going to print it, I would print 3 because it'll help hide the infill lines from showing through, which means less post-processing for you. If I was printing structural, for example, ear savers for the pandemic right now, 0.2 or 2 walls is just sufficient. It's fine. It's quick. It will work. If you're printing like a shelf holder and it needs to hold weight, go back up to 3, 3 or 4, and that will give you strength. Infill has very little, most of the times, put a pin in that, but most of the times to do with strength. Infill is all about printing the top of the model because you can't print over thin air. So you can see here that Baby Yoda has that infill that goes all the way up so that this interface, the first wall, has something to sit on. So that's the first part of infill. The second part really touches on Aaron's question. I don't want infill everywhere. Well, there's a few ways to achieve that. So the first way is using that infill overhang. So let's take a moment. Everybody take a mental picture. Click OK. That's what our normal infill looks like. We're just going to pop down. We're going to come to that infill overhang settings. And remember, I got my shell open, sorry. So remember, that was a checkbox, and you're only going to see the checkbox if you have enabled all of your features. Check. So what this does is tell the slicer that unless the overhang of the object is greater than 65, it won't bother printing infill. So you're going to cut down your print time dramatically by changing this, but you also reduce the amount of infill automatically. So this is more of an automatic way than a targeted way by the user, the manual intervention. And oftentimes it works just fine. So we're just going to hit, and again, that's infill support. And you'll get the overhang angle when you start to see it. And then what happens with that is it'll automatically calculate your support angle and fill less in. I'm just going to throw it back to Greg for a second here because he has tree support sliced. So,
Okay, so if you look, it's got now creeping up the side these little hands holding the edges of the helmet, and if we slide the slider down, the center is a lot less material, and you see how it's kind of growing branches. That's why we call it tree support, to hold the different angles. So this is a way to save material when you're printing. There's another way to do helmets, but I think David's going to talk about that a little later, I think. But we'll go back to Baby Yoda now.
did you miss him, Baby Yoda? I sure did. So remember, we just changed the infill support overhang. That was it. And that's in that infill menu. And then now if I bring up my slider, the first thing you can see here is non-uniform support being generated. You can see there's little gaps here and little gaps here and little gaps here. And that's on the first few layers of a support. So here's the side view. So what's happening is it's actually deciding more tactfully where to put that infill. So as we go up in the model, we can see that there's a lot less infill now around this perimeter. See all that yellow space that we can see down through right now? This is layer 90. You can tell by the layer slider on the side here. But we can see that it's starting to reduce the amount of infill. And the print time's actually down slightly from what we were before. Not a whole lot in this case because it's such a small model to start with. So saving like 3 grams of infill isn't really going to affect too much on print time. But you can see here, like look right in this section. There's no infill until layer 230 in his arm. So what that means is the model is actually capable of printing up over by itself. Now, you can judge a model once you start practicing a little bit. You can judge if you need infill at all. Some models are capable of being printed without infill. And like I have a really good example I will grab in a second of a model that looks like you'd need infill, but no, you can print that thing perfectly hollow. So this will save you a little bit of time just by the auto tools. And then as you go up, it really becomes evident on his head, right about here. See, look at all that green space inside. It's taking out all that infill automatically for us so that we don't have to waste that filament where we don't need it. And that's partly because 3D printers can bridge gaps. So if you have small gaps that are across the model, it can actually just print in midair. And we'll show you a little bit better example of that too. But bridging is a powerful feature of our slicer, which can reduce the amount of infill or even support in some cases, not all cases, that we need to use. But as we go up in the slicer here, I'm just going to, there we go. You can see that the only real support that exists now is closer to the center of his head. So that's in a nutshell Baby Yoda. Now, there are some issues with this model that I'm going to show you how to fix. And it happens quite frequently on models that have curved tops, so rounded tops. And there is a way to fix that. But that's one way, Aaron. I'm not sure if you were aware of that and if that answers the question completely. There is another way. And the other way actually happens when we add modifiers and per model settings. So we can actually add per model settings in Kira and Prusa Slicer. And pretty soon we're going to shut down Kira here, and I'm going to show you just Prusa Slicer in about 4 minutes. So when you're dealing with per model settings, there's actually something really cool that happens in Cura. And this might be more to the point, Aaron. And well, obviously everybody else. It's not just for Aaron. But this might be more to the point. So support blockers exist. Support blockers are a feature in Cura that actually lets you pick a model and put a block on it. That's a really bad spot for a support blocker. But support blockers where they exist will actually, you can move them around just like a regular model in Cura, and wherever that model touches, it will block supports from actually happening. So if you're finding where you're having problems with over-supported areas, or you know for a fact that your printer doesn't need support, like right here, it might print just fine, but out here, we probably would want support. And even on this model, you almost could print it without support. That angle is just a little shallow there. But once you got to the tip, just let me, so once you got to the tip of the ear here, right here, you probably don't need supports anymore, right? And if you look underneath, your slicer actually gives it a little more here. So anything with the red is the support overhang threshold. And again, if you don't know where those settings are, it's in support. You have to click generate support to see the menus, even if you're not using support. And Kira's thinking about it, so we'll just give it a second. But the support infill settings, or sorry, the support overhang, wow. Support overhang settings are definitely right here. Must be time for a piece of candy or something, I think. But yeah, so you can see here that I have mine set at 50. So anything over 50 degrees will actually require the slicer to auto-generate that support. But let's go back to infill. So we have our support blocker. And we'll use this as a terrible example. Go away. Go away. Thank you. But let's say we don't want infill for his whole head, which you do. But we're just going to say we don't. So we're going to take our support blocker once Kira wakes up from its slumber again, and we're going to make it bigger. We'll make it about the size of his head, and then I'll show you how to use the per model settings to adjust the infill ratio of his head. So we can go there. That's nice. Little less. Come on, work with me. Let's go 400%. There we go. And then I'm going to go to the move, and then I'll just kind of center this on his head a little bit. All right. So now that we have this block here, you can come down to this per model settings. So click the, where'd my block go? Dang it. There we go. Control Z. It came right back. So select your block, and once Kira catches up from the blue wheel. So I know a lot of you aren't having this issue with Kira. And I'm happy for you because yeah, we've got video streaming running, audio, and all the other stuff. So we're taxing our system. Sorry. So I know David's favorite is. All right. So we go in and we're going to go to this per model settings, which brings up the per model settings. And you can see here on the right hand side, since it's a enforcer blocker, the first one, it says don't support, but you can actually modify anything you want about this block. So let's say we want to do, you know what? We could do normal mode, or let's do modify. And then see right here, you can go infill as mesh only. And once Kira catches up again, you can actually change the infill percentage of that box. And then everything. You can change everything you want. And there's even a select settings if you don't see what you want. So we could say infill mesh only, select settings. At the bottom, it brings up all of our wonderful settings, and we can go infill density. And this is the blow your mind moment. Or not. You can change the pattern if you want midway, or the density. So right now our density is set at 10% for the model. So as an extreme example, this wouldn't probably work, but 0. All right, so I'm going to go 0, and then I'm just going to click off, and it will very slowly save those settings, and then we'll hit slice. Now, once you do that, it will change the infill settings. I'll show you what it does, but this is the way that you can actually block supports from happening, or infill from happening in Kira. So we'll hit slice. Now, we'll come back to Baby Yoda in Kira, but we are going to switch to Prusa Slicer. People often ask, and I know probably Greg has fielded the question too, but people often ask, which one's better? What slicer do I use? Because there is literally, like on my laptop, I have 7 slicers installed, and I've probably used them all at least twice in the last month.
It depends.
Right, it really does. If you are printing a model such as Baby Yoda or a minifigure or something like that, Kira offers those tree supports, which are just perfect, right? However, I have found that Prusa Slicer can produce better prints faster for most cases. So if I need tree supports, that's my go-to, Kira. That's my answer. If you need tree supports, Kira. If you need to do anything else, Prusa Slicer is just faster. Now, there is another juggernaut in the slicer field called Simplified 3D. We're not going to show it today. There's a few reasons why, but one is that it's about $200 Canadian to purchase. Yeah, and it's 3 years antiquated. It's a very good slicer, but the features in Kira and Prusa have surpassed it now. So post-processing and stuff like that is a no-brainer to do in the other slicers now. You don't need the simplified powerhouse. So I'm just gonna let me flip back to our Baby Yoda here. I'll generate my preview. And let me screen share. So I accidentally supported it, which was my bad. I left that on. That's okay. But look, this head's hollow. Everything's hollow. So I've actually overridden the setting for the infill, which is really, really cool. And you can do any setting basically you want to override like that. So if you wanted to add more walls just on one part, if you wanted to override the shell thickness, same thing. Speed, you can do it. So yeah, it blocked it because I had the supports on. If I would have shut supports off, it would have. So when I blocked it, I accidentally left my supports on, and that actually screwed up the slicer. There's a few bugs in Kira, and this is one of them. The other one is that you can actually accidentally generate tree supports with regular supports, in which case, just throw your model away. You ain't getting those off. So we're going to switch to Prusa Slicer. So let's have I don't know, what's a fun emoji? Everybody post your best memes if you've got Prusa Slicer installed. I just want to see where everybody's at. So Kira is very good, don't get me wrong, but Prusa Slicer just has some features that edge out Kira. So 3, 2, 1, shrink. Okay, so we're going to go into our Prusa Slicer. This is what it looks like. If you're first loading it, it will load the configuration wizard. And this is a fresh install on this computer for my Prusa. So we'll just run through it together. We don't own Prusa printers. So basically these first 2 sections, so Prusa FFF and SLA. So remember, FFS is fused filament fabrication, and the MSLA is the something cinder laser. I don't even know, but it's the one you print with resin. Greg has the dog head going on. So we're gonna go other vendors. So this is a recent change, but if we click other vendors, you get a list of the printers. We own a Creality printer. And we're going to click next. And then you can see here that the Ender 3, it's important to note that even though this says Ender 3, the Ender 3 Pro has the same build dimensions for the most part. So we're just going to click next. And then next. Filaments, you can leave the generic ones. They're just fine. They're good options. they always show the Prusa stuff, which is really good choices as well. So basically, the filament settings just sent the temperature of the print head and the print bed, and other features that we'll show you in a second. I always leave that one on, check for updates. You can also update the built-in presets, which means if there's like a change to the filament brand, like Prusa, for example, although that stuff's really expensive in Canada right now, you can, it'll automatically update those. We don't have anything to do here. We don't have any path names that we need to worry about, so we'll just click next. Greg talked about it in Kira. We talk about it here. I think that if you leave Prusa on simple mode, you're crippling yourself, just like I do in Kira. I think that you should totally have all the options on, even if you don't use them all. There's no harm in having them all on so you can actually see what you're working with. So click expert mode, click finish, it'll load. And you can see here on the side, it actually changed some detail stuff. So I have 0.12, 0.2, 0.24 as my print settings. And if you were all following the scoreboard with the Creality printers, remember that the layer height goes up in 0.04 increments. So we can print at 0.12, we can put at 0.16. It's not listed here, but we could. And then 0.2, 0.24, and so on. So it's just math, but it's in 0.04 increments. The ABS is something we don't use, but we get the option for generic filaments here or Prusa. And generally speaking, we'll stick at PLAs. So you can print, you can pick either the generic or the Prusa. And then right now, the only printer we have here is the Ender 3. Now, there's some changes that we have to make to the build platform, because if you notice this white line, all the way around, the white line is actually because on the Ender 3, it uses bed clips instead of the magnetic beds. So the clips actually take up about this much space on your printer. So that's why this white line is there, and they actually just block the edges off at the same. And Kira used to do this as well. So we'll fix that. It's an easy fix. We just go printer settings. So if you didn't catch that, it's the settings gear beside printers that I clicked. Or you can pick the tab. They take you to the exact same spot. So you can see here that we're in our printer section. I'm going to click the general tab. And then from here, it actually shows you what kind of setting it is. So if you notice, advanced is yellow, simple is green, and export is red. So anything with a yellow dot means that it's an advanced setting. So if I switch back to simple view, you see all those settings go away, which is sad panda. All right, so we're going to go back to expert. We're going to go to general. And in general, we just need to hit this bed shape and click set. And then here we're going to type in the 235 millimeters that the bed actually is. So if you have a glass bed, oh, and I see Andy just asked, so hey, there you go, topical. You don't actually lose build volume on the two outside edges of the plate. So setting it 235 by 235 is just ducky, but remember that the clips are there. So when you, in your mind, when you're putting a model on the plate, don't put a model where the clip would be, because then it'll either A, knock the clip off your bed, or B, ram the soft brass nozzle into the clip, and you are the brand new winner of a new brass nozzle that you have to pay for because nobody's actually going to win. So we have here, and you can see it kind of changed back to this lovely grid. Now it's modified right now. You can see here, as soon as we changed it in our printer settings tab, it modified it. You can hit save. And it won't actually let you save over the default one. I don't think it did. Let's see if they changed it. Yeah, because that's a system profile, which means it's been generated by Prusa. Don't touch it. Bad, bad, bad. So let's hit save, and we're going to call it like David Ender 3. So it'll take just those settings that we just made in that window, and it'll save them for us. Now it's called Ender 3. If we wanted to, we can look at the platter, and it's boring. Look at that boring platter. It doesn't say Ender anymore. Sad. You can go into your print settings where we set the bed, and you can actually load that texture back. It's inside the program files folder for Prusa. So it'll be C, program files, Prusa 3D, Prusa Slicer, resources, and I think it's profiles. And yeah, so there it is. So for those of you keeping score at home and want to add that in, here you are, a gift in chat. That's where the SVG lives for that. You can click open, you click OK, back to the platter. Oh, look, it's back. Yay. And so now the printer's the right size. It still says modified on our printer. That's just because we didn't hit save. So we don't want to actually unload it. We'll go back to print settings and hit save. And it will let us overwrite now. So when you hit save, you can just click OK. And it won't ask you to make a copy of it or anything like that. The original system one there, if you need a reference. But that's roughly how you set up the Prusa Slicer with your Ender 3. Now, remember those two print control methods we talked about at home were Octoprint and Astro Print. Well, there's an Octoprint right built in for printer host upload. So you can select your Octoprint instance, or Octoprint actually has a discrete port you can listen on. So if you hit browse, it may list it up here. I say that with very little faith because it only works about 50% of the time. So all you need to know really is your IP address of a printer that you have. And then you need the API key from your printer. And that's found in Octoprint in your settings gear. So, oops, where do we go here? Oh yeah, this one. Sorry guys, I'm playing browser mashup. So you would go settings, and then you would click AP, and it will show you your key. So I'm going to do it off screen because I don't want to show you my API key and have to regenerate it. I might have to anyway. So all this security may be for naught. So I've copied, I'll just show you. This is what it looks like. So when you click the settings, you click API, and there's your key. You can either double click and copy, or just click the little clipboard, and then paste that into your Prusa Slicer field, and then hit test, and it says, yay, it works. And now, when you want to slice with Prusa, and I'll show you in a minute, you can actually send the file right from Prusa Slicer. The other thing that you want to be sure is selected is in the firmware. Underneath, it should say Marlin. So just make sure that it says Marlin down there, and life will be just ducky. So now that we're done on this screen, we'll hit save and save. Now, we're lucky in the fact that this comes with the Ender 3 G code at the start and end, and this is still in print settings, just custom G code. The little comments actually tell you what it does. So it's awesome. You don't have to memorize them. I will say though, if anybody does anybody have the BL Touch on their Ender 3? I know. I think we have Andy does, and I thought maybe Kurt. I thought maybe, but if you have a BL Touch, every time you start a new slicer, look for this G28 command, which is home all, and then right after it, put in G29, and then you can just say auto bed level. So that's G29 semicolon auto bed level, and that will actually trigger your probe. So every time you slice, this start and end G code gets injected into your model. So at the start, it looks like this. At the end, it will look like that. And I will show you in a second. So that's basically the setup. The machine limits and stuff, we can play with that to our heart's content. But everything is actually set up now for a stock Ender 3. So, and again, they just give you warnings here, so that's fine. So we'll go back into the filament setting tab just to show you very, very quickly. So if I click filament settings, you can see that the Prusa settings say that it will print at 215 on the first layer and other layers, and the bed will be set to 40. If you drop down in this menu, you can click PLA, and you can see that it's the same, except after the first layer, it drops it down to 210. So honestly, what I like for my PLA, and I think most of the people will agree, is 60 for the bed. So I changed this number to 60. Now, the reason for that is the glass transition heat for PLA is 60. Now, that sounds like a lot of fancy words, but what it really means is PLA starts to adhere to the build plate at 60, which means if you have PLA out and about in the wild, like let's say you print a sweet new gear shifter for your car and you put it in your car on a hot summer day, it's going to get above 60. And 60 is where PLA starts to deform in the heat as well. So your bed temperature, and we have that in that slideshow where we show which filaments you can print, and the transition temperatures are on that as well. It's also printed on the side of your spool box when you buy it. So there's two sources. And then the other thing is I generally like to print at 210 for my PLA all around. Some of my PLA likes 200 better and some likes warmer, but 210 is usually where I keep it, and that's 90%. Like there's two rolls. Like this is a great starting point for your PLA. There's things like temperature towers that you can print and modify, figure out what the best for you is. But in Southern Alberta, with the humidity and stuff like that, 210 is a really good place to start. And generally speaking, your prints will turn out really good. If you see stringing on your prints, so like the little wispies that print across gaps sometimes, that could be the retraction settings, but it also could be the heat of the filament. So in Kira and Prusa Slicer, the retraction speeds can be set. Now, the retraction speeds in Prusa are set on the filament, I do believe. So here's the retraction speed. You don't really need to override them, but per filament, it's nice to know that they're here. So if you do get those little wispy strings, and I'm going to post something in the chat that you will appreciate, and it might blow your mind. So the retraction speed that I start with is 45 millimeters per second. I'm trying to type and talk. 45 millimeters per second. And the length is 4.5 millimeters. So that's 45 millimeters per second or 4.5 millimeters. This works good for both the PTFE setups and the actual Micro Swiss all metal hot and upgrade kit. So that's a good thing to keep in mind. Everything else in our cooling rate, or in our filament settings, should be just fine. So again, we modified it. This is a system one, so we're going to hit save, and we're going to have to rename this. So let's call it David PLA. And then in brackets, I like to label it like this, so then I know that that one's my 210 PLA. And then I can just go, okay, and it will save it. So we've done print settings. That's this screen here. This is basically the meat and potatoes of what your machine can actually do. If you wanted to set that overall retraction settings in print settings as well, it's extruder. And then you go down to retraction speed. So then I can tell my retraction speed is 45 millimeters per second. And I can also tell it if I wanted to add more on the length up here. And that would be 4.5. So you can see that if we only had the simple settings on, we would be missing almost everything we just changed. So like if we look at filament settings, our temperatures would have been there, but we wouldn't get those overrides. All of those would be missing. And we also wouldn't have saw the retraction speed. So that's why it's important to have that expert button up here ticked. So if at any point you're on simple, and you only see a few things, remember, click expert mode. Same thing for Kira. Just make sure you have that check on. So we'll click save. We don't have anything modified. We don't have anything modified. The last thing is print settings. And honestly, these are really, really good to start with. So the layer height, if you guys aren't aware, is how high each layer, how high the nozzle moves up before it starts each layer. There is some discussion on layer height and strength. So some people subscribe to the larger layer heights. So like if you have a 0.4 nozzle, the biggest you can reasonably print a part and actually have it look like the part is about 0.36 millimeters. It's usually about 80% of your nozzle size. So if it's a 0.4, you could multiply that by 0.8 and you'd get a number. But 0.3 is, or 0.36 is the outside edge. And if you increase your layer height, you decrease your speed, but you do sacrifice some quality. So remember that if it's functional, bigger layers, but you will lose some quality. So even bigger nozzles, like a 0.8 nozzle, I love them, but be prepared for prints that look like the Michelin Man, because the big layers cause that. Now, one of the biggest difference between Prusa and Kira is where they start to talk about shells, and this is part of the reason why Kira is Prusa looks better than Kira out of the box, because our Kira settings by default, when we look at the shells here, are 2, whereas this one is 3. So more walls equals smoother outside equals nicer looking print. Now, I'm just going to shrink that window down for us. So when you're printing on an Ender 3, how many people are printing on that flex mat still? So you still have that flexible magnetic build plate. How many people? I've had stringing at 200, so I should look at retractions. You are right, Andy. If you have stringing and you're around 200, you should probably look at the retraction settings first. If neither of those help, it could be an issue with the PTFE tube not being set all the way into. So heat it up, try to push that PTF down the coupler a bit harder. So if you're using the flexible build mat, one of the best things to do is start with a skirt and a brim. And that's available in both Prusa and Kira. So in Kira, we can look at the bed adhesion. And you can see that mine set to none, but setting it to skirt just gives you a little extra around the model. And the reason for that is it does draw a purge line along the side of our printer by default for our start G code. But if we don't have on that magnetic mat, you're still going to get a little bit of oozing that goes along it. And so drawing that skirt gives you one more barrier. But it's important to note that, like you can see in Kira here too, let me give you a top down in Kira. They're both the same. So if I select none, you can see in a second, because Kira, but you'll see this gray outline box in the background here change. So see, now it's white. So if you're wondering where that box around the outside comes from, it's because it's giving math so that that's the skirt distance from the model. So it says if your model would take up this much build plate, boop, so the whole white area, or I guess light gray, but we'll call it white. That's how much space on the outside it would need to actually print a skirt. So that's why it's saving that space. In Prusa, it actually doesn't show you that. So here's our print bed, and I do have let's drop our baby Yoda, boop, in there, and I do have the supports turned on, or the infill turned on. So let's go back into our print settings and skirt and brim. You can see loops 1, distance from objects 2 millimeters, skirt height and all that stuff is there. You can leave skirt height at 1, which means it would just do 1 loop and then start printing. What I like to do is 2 loops, and then I also like to do 1. Now, there's a cool feature called an Oozy Shield. So if you're getting drafts on your prints that's causing warping and stuff, after your first slice, if you know how tall your model is and how wide on the build plate, in Prusa, you can come here and actually tell it that, okay, so loops minimum should be 2, which is fine. And then you can actually modify this and they give you this draft shield. So once you have these settings and click draft shield, it'll print like a little column up around your printer. So it's like almost like a vase that it can print in, and it protects it from the drafts from the room. So Prusa Slicer, that's the setup for all of our settings here. We can leave this one as default and modify as we need. The ones that you're really going to be modifying are probably your layers and your infill. The support stuff is fine. By default, it's off, and you can change that in the slicer itself once I'll get there. But we can see that all these other settings, like the top and bottom solid layers, yeah, it's kind of excessive, but you're going to get really nice prints at that. And that's just part of the Prusa experience. They want to give you the best out-of-the-box experience to have awesome prints. So our baby Yoda is on our build plate. We can see here on the side, we can have some override settings. So we do want supports, so we can just drop sound supports, support on build plate. Supports work better in the following features enable: detect bridging perimeters. So Prusa is automatically going, can I just bridge that? Okay. So you click yes. It automatically adjusts that. We can bring our infill up or down here. And the same way that we modified it in Kira with that, remember the little gray block, our block guy? And we used this little support button to get him. Prusa has the exact same thing, except it's even more convenient because you right-click the model, add a modifier, and you can pick the shape of the modifier, or you can even pick the kind of the modifier off the bat, and then you can change it right here. So we're just going to very, very quickly, I'm going to shut this menu. We're going to leave this at 10%. We'll come back to this in a second, but let's just hit slice. So look, my mouse is not frozen. Please note that there's no dying, spinning wheel of death. The slice is actually like a third complete already. And as you go along in the slice, it'll actually pop up a preview before it finishes, which is kind of sweet. But like, we're almost there. We're on the last eighth now, and it's not even been 30 seconds compared to Kira, where it's like, well, Greg, let's pass this off to you so we can talk while Kira's slicing, right? The weird part about Kira is the orbiting system. It's completely opposite of, Prusa is the orbiting system. It's completely opposite of Kira, except for the center mouse button, which moves and pans the plate. But you can see here that even though they're not tree supports, it's actually generated a decent support structure just automatically for us. Remember when I talked about the ear? You wouldn't need it past there. Well, it already realizes that. So Prusa is a fairly robust slicer, and it just keeps getting better. You can see at the top of the head here that there's still this mess. So there's a way we can actually fix that in both slicers. In Kira, it's called adaptive layer. And in Prusa, it's called variable layer. Okay, so in Kira, let's just get, did I anger the Kira monster? No. So in Kira, no worries. We're just gonna size the video, guys. In Kira, you can search for your settings in the menu here, and then up top, right where I'm typing, if you type I even typed add and it showed up. So adaptive layers is an experimental settings, so you don't have to remember where they are, just remember what they are. So adaptive layers, and then you can see here adaptive layer maximum variation, adaptive layer variation step, and adaptive layers topography size. Man, I can't even talk today. Sorry, guys. 0.2. So this actually sets the parameters for our layers. So think of it as this. How far each layer do you want it to be able to go up, and how far do you want it to step? So if we were to just hit slice on this, I'm going to leave that ticked, but I'm just going to change my support so it doesn't generate on the slice. Boop. Okay. Oh yeah, and tree. So we should be okay. And yeah, that's good. And then you know what? I'm just gonna delete the support block once Kira lets me click things again. And we'll go and we'll slice this one. Let's see Prusa. You guys are gonna love this. So that's adaptive layers in Kira. We just typed adaptive in the settings. It was literally, let's just leave it at default for now. And then we'll hit slice. So here's our model. Here's our adaptive settings. Again, AD, and that's it. That's all we changed. So let's slice and we'll see what happens. Prusa. So I can grab this and then this button in the tab up here. Everything is so nicely laid out in Prusa. It's such a well thought out program. It's actually used to be called Slick 3R, but Prusa took it over and has made it something amazing. No, the last update to Slick 3R. Sorry, Greg's in my ear and you can't hear him. So there is a Slick 3R still. That is a good point, but it hasn't been updated for 2 years. So it's the same version. So once I click my adaptive layer height, changes the model. It tells you left mouse, add detail, right mouse, remove detail, shift left mouse, reset to base, right? So it gives us all of our options. So first off, we're going to look at our model. I'm going to rotate him a bit. Rotate and just move him out, move him around. So we can see here that really the problem child areas are up here. There's holes in the head. There's stuff that I just hate. So if we move our mouse up and down the side, you can see that yellow highlighter on the head. So I'm moving my mouse on this bar on the right-hand side, and there's that yellow. Now, if I want to add detail, according to the variable height menu, I will use the left mouse button, which means you can see the little bar go down, and I can actually paint his head like this. And let's see. Yay! So it's going to add detail. Now, I can do adaptive as well. So if I choose adaptive, it will auto-calculate for the whole thing. Or I can smooth, right? And there's actually some variable settings that you can modify in the print settings. But for now, we're just going to go with default. So what we should see now is a little bit better. And we can change our quality and speed down here. So if we need more quality, where we actually have our lines, we can slow the printer down, right? And smoothing radius is actually a function of ironing. So once we have that, so I've made his ears better. That's the first thing. I can look and see that, on the top of his hands here, boop, 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 boop. You can see there's a little weirdness. So let's move our slider up and down, grab that, paint it. So I'm clicking the right button and it's adding detail basically. I think I'll add a little up here too. So it's important to note that like it didn't just add it to the finger, it added it to everything on that layer, which is just okay. It will work out just fine. Okay, so we did all of that without Prusa Slicer freezing or crashing. I'll hit slice now and look, it started slicing right away. Kira. If we hit preview, in Kira, just went back and hit preview and it's in a deep slumber again. So it's in a slumber process. Prusa is almost done. It's about halfway there. Kira's still working on it. Let's see. Is Prusa going to beat it? It's so close. Okay. It was close. It's generating our preview for adaptive layers in Kira. So we can see here it didn't do a lot of change in Kira right now. So we'll have to go back and change some of our parameters, and I'll show you exactly which ones to use. But that's adaptive layer first, go in Kira. So let's check out Prusa. And let's check out his head. Yeah, there's a lot less of the yuck on his head just from the first pass of the adaptive layers. And you will not notice by naked eye usually some of these blemishes. So if you can see the white, that's a gap fill, which means the slicer doesn't actually know how to draw that circle in. So it's just going to deposit some filament. And then the orange in Prusa is our outer wall. So all in all, I think Baby Yoda here would look pretty good. I think he would look really good. And then in Kira, we can go back, we can change this, we can go adaptive, and then we can go in here and we can change our size topology. Greg's having a fun time. Every time I switch between Prusa and Kira, Skype resizes the video. Sorry, guys. I promise I'm only going to switch one more time, Greg. Probably. Maybe. So let's change that adaptive layer typology size to 0.12, which means that we're actually going to be going start at a lower. Actually, you know what? Let's give an extreme example. So we're going to go to the lowest print setting layer height wise that you probably can get out of your enders stock, which is 0.08. And I'm going to break the planet because, well, now it's important to note that in Kira, the adaptive layers don't have the slider option. You're getting an all or nothing shotgun. If you wanted to change the layer height, go back to the adaptive infill we were talking about before. And instead of infill, where we added those settings on our model at the select settings, you can add shell and walls, and you can change the layer height if you wanted. So we're going to leave that at 0.804. Looks good. Let's hit slice. And now we're really going to break Kira's brain because that is a lot of work. So we'll leave that go. There's one more thing that I want to show you in Prusa Slicer, and this is one of the biggest features that just keeps me coming back. And that's the fact that Prusa Slicer has built-in model repair that works. So you can see Baby Yoda in our sidebar, and you can see this explanation point. So he has 32 errors. So even though this model looks solid, and we're looking at it right now, there's 32 errors. 4 backwards edges, 6 edges were fixed already, and 22 reverse facets, which means the triangles are flipped and backwards. So that could actually cause problems with extrusion, and some of those white gap fills are due to that. So if you click the explanation point, or you can right click and go fix model. But if you click it, I just right click the explanation point. It automatically starts loading the netfab module, and it exports it, and it will go through. It takes, depending on the size of the model and the number of errors, it could take about 30 seconds. Or if it's a huge model, it could take like 40 minutes. So it's just important to remember that when it's repairing the model, it's a patience game. But it's something that you need to do, and Prusa has an engine that actually works in it, and it works well. By itself is a very expensive piece of software. So our Kira preview has sliced. Don't worry about it, Greg. We're just going to look at the top of the head. So if it resized, we're good. I'm going to hit preview. Okay, it's fine. We're good. Okay. I'm hitting preview. Come on.
Come on.
I've angered Prusa, or Kira, so we'll go back to Prusa and just see how the oh no, there it goes. Okay, and Prusa is still repairing, which is fine. It says not responding right now, and then it finished. So, all right, let it do its thing. So you can see here, if we switch the line type and we switch it to layer thickness, you can see what the adaptive actually did. And so it basically said that the whole model needs to be really, really good. So the dark blue on the model and the layer thickness is 0.16. As you get more to the green-ish in the middle, it's 0.2. And the yellow portion is 0.24. So it actually went a little higher than the default quality of 0.2 for our model in that adaptive slice. But it's saying that 90% of the model needed to be printed at a better rate. So yeah, and 4 hours and 21 minutes later, you would have a Yoda, and it's I think we were at like 2 hours in Prusa. So the adaptive does work, but keep in mind that those settings, if you up this maybe to start at 0.12, so that's the smallest layer you'd have, and then you can go up in variation size. So even if you went up in 0.8, and then leave at 0.4, so 0.8, 0.4, 0.12, we could probably cut down on the layer time and still end up with a decent model. We would probably see, though, as in this one we start at 0.12, it would start at 0.16 and then go up to 0.24 again. So let's see how we're doing. I'm bogging my system way down. So I think I broke the computer by doing all of it at once. Hold on. I'm going to close this. or maybe I have to do it the old-fashioned way. Okay. Okay, we're good. I'm not going to attempt it again because I got a lot running. But remember, that button is there. So we can see here that I have a slice. It looks like this. This is our Yoda slice. Remember when we set up our Octoprint settings? You can click this little G button at the bottom and hold on. I'm going to move my head, people. 1 second. Watch this. I'm going to be not in here for a second. Oh, la, 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 la. Gone. Okay. So down here, there's a G button, and that will send it right to your printer. It pops up. It says, do I want to start after printing? If your printer's online and connected, you can. Mine's not online. It's not on, but my Raspberry Pi is on. So I'm just going to send the G-code file. So I'll leave that unticked. I'll hit OK. And in theory, it should go. If you click Window and you can go the print host queue, you can check on the status and you can see that it's uploading. So yeah, that's Prusa Slicer in a nutshell. And I gotta say, I enjoy using it. I'm gonna throw it to Greg for a second, and then we'll come back with some final.
All right. So, any questions about Prusa Slicer or anything else? Because I think we're done with the main demos. Now it's Q&A and answering any issues that you have. So any questions, please throw them up now. And then and if there's something that maybe we went too fast on, we can definitely go over again. I need to clean my office. Yeah, well, I got a lot of stuff going on. Andy was asking about which should he do first. Distance. I think Kira by default puts your retraction distance at 6. That's way too high for most Bowden printers. They try to be cautious, so change it to 4.5, and then if you have to, if you have no movement in your in Bowden tube, I don't think I have a Bowden tube on me here, but if your Bowden tube has no movement on either end, it's nice and stiff, you can even get that down to 3 millimeters and whatnot of retraction, but it really depends on your printer. I'm going to go to split screen here because David is back. So
sorry, guys. Greg needs to clean his office. Hey,
let's use.
It's not a question.
Let's us Cura users switch to Prusa for a while. Yeah, you could. Feel free to try. Like, there's lots of other slicers out there too. There's some experimental ones, or not experimental, but early development ones like Pathio.
Yep.
There's a number of them out there, and feel free to try them. Like some of them are online, some of them. I go back and forth depending on the model I'm doing. I know Kira quite well, but I was telling David the other day I was having a problem with my printer, and it ended up being that I must have messed around with some slicer settings and messed it up enough where I was not getting consistent prints. So I just went back to defaults, which is always nice. You can always go back to factory defaults, did a print, and it was almost perfect. So it's just something to be aware of. Feel free to experiment. That's part of this hobby, is to learn and experiment. And don't be afraid to click a menu and try something out. Don't try 5 things at once, because then you don't know what changed. But if you're not sure what a setting does, and you have a small model and whatnot, try it out. See what it does.
For sure. I mean, the online slicer in Astro Print as well is the exact same settings that we just showed you in Kira.
Yeah.
The online slicer is available when you use that design library button, and when you hit slice, it's using the Cura slicer settings. I'd maybe just switch back to my screen share for a second, Greg. So if you go down into this tab here, and you can go on my slicer in the Astro Print, and if we just look at my CR10.2, yeah, here's all of our Cura settings. So here's my quality, my line width, everything that was in Cura. I literally can just open Cura beside this window, transfer all my settings that I want in, but you will notice that the number of settings is a little bit more limited, and that's because they're using Cura 3.6 in the Cloud Slicer. But I mean, it's again, it's another great option. And if you're in your design library and I wanted to print any of these models, so like if I looked at my Baby Groot model, it actually already has been sliced, so I can slice again. And here's what it looks like. It's a super simple interface. It asks you what printer, it asks you what material, and that all gets set up with your account when you create it. Choose your quality. This is where I choose under here the radio button, and then I can pick my CR10 that I specifically set. But there's absolutely nothing wrong with using these normal ones just to get started. Do I want support? Nope. Do I want adhesion? Nope. 10%? Yep, that's fine. I can change the settings even from this print screen. I don't necessarily want to, so let's just hit slice. The one thing I will say is Baby Groot, he's one of those models that prints without infill. So 0, and then slice. And then after that, it will run through, and it's just like Cura. It will say, okay, well, I'm sliced. Do you want to print me now? If you hit print, since we've already chose our printer, it will send it to your printer right from your web page. So this is all web driven. So yeah, that's it for Astro Print. So we'll switch back there. Yeah. I'm just gonna grab
So I hope, yeah, and David's famous for finding models and printing them, and he prints them fast because they're hollow, no infill.
Yeah, no infill. So Pikachu, hollow, this way, right? So this is an example of a good model where you can print it hollow, and I think I printed this one at 120 millimeters per second, and it was about 230 degrees, so the filament could extrude. But that's just an example. This is off an Ender too. This is an Ender 3 print, Pikachu. And then
so remember, if you crank up your speed, beyond a certain level, you need to up your temperature so you can get enough flow of plastic.
So, and this is the one we were just looking at, Baby Groot. He's hollow as well. If you want to see a bigger example of Baby Groot, you see on my desk.
Yeah.
If you ever buy the Knock Come On In, we've got a bunch of prints sitting around that are really good examples, and this is another guy that prints completely hollow. So you save filament when you print models hollow, and I can't break it.
It has 3 layers.
Yeah, this one has 3 layers. So if you did this with a 2-layer model, you would break it. Did you mention the other day that you could use one of the slicers to split a model? Yes, Aaron, I did. Let me just throw it back quick, Greg. Yeah. And I will, unless you have Prusa open. Let's see here. Okay, let's grab Prusa. You can actually, that mesh tool in Cura that Greg installed, when you right click it, and when he did the check model, it works as well. But here's my Prusa. For some reason, let's cut Baby Yoda in half, which is fine. We'll cut him in half. So it's just loading my model. One thing to note is that fancy build plate we added in does increase the load time of the models slightly. So when we click Yoda on the side here, so we have like rotate, or if we click this one, it'll lay it on a face. But the very bottom one is cut model. And you'll see here when I select this one in Prusa, and it goes up and down, up and down, up and down. So that little orange one will change the slice point. So if you wanted to cut this model this way, you can like move it where you want to. So let's say we wanted to decapitate him to cut his head easier and just glue it back. We can do that. So we can keep the upper part, we can keep the lower part, or we can keep neither for some reason, which would be weird. So let's keep both. We'll perform that cut. And you can see it's going to be really weird, but it takes his head off, drops it to the build plate, and puts them side by side. I mean, I would probably do it more carefully if I was doing that to this model, like to print, obviously, because I don't want the extra stuff. But let's say we don't want that cut in Prusa. Instead of Control Z, which you can use, it gives you a history of all your movements. So if you right click the back button, it'll show you all the things you did, and we don't want to cut, so we'll just do the oops, sorry, wrong one. So the next question, and I know it's going to come up, and Greg just mentioned it too in my ear, is can you cut it vertically? Yes, you can. So when you cut right now, you can see that the model's like, well, it won't cut. So that's where this comes into play. We can rotate the model in the slicer. So just bloop 90 degrees like this. Now, if you grab the ticks on the outside, it'll snap. If you want like an exact degree, you can go inside or outside. And it also snaps to the inside ticks if you hover. Oops, I pushed a button on my mouse. I'm sorry, guys. So that is, and Kira does not do that, by the way. Kira is the slowest at rotating and the hardest. So I rotated it. It's laying flat now. I can perform the same cut. And I'm using his nose as the guideline here. And I'll keep both parts, perform cut. And it'll chug away because it's a bigger cut. And now you can see it laid the one half of Yoda down. And this will probably print without support now, except for the little hand. But do you see where I put the other Yoda? It put the other Yoda on the ear of this Yoda, which is fine. We can fix that super easy, though. If we click this one above the cut, place on face, and it'll give you a highlight of all the little face that it has, but we'll pick this big one. It'll snap it to the build plate. And then in Prusa, if you hit the A key, it'll auto-arrange your build plate, and it's done. In Kira, you can also do a face. It's in the rotate menu, but it is definitely not as nice as this because it doesn't give you even a hint as to what your model will lay as. But yeah, we have two Baby Yoda split in half. Well, one Baby Yoda split in half. Technically, isn't that the whole premise, like the cloning thing? I don't know. Spoilers. Anyway, that's Baby Yoda, and that's splitting in a slicer. If you wanted to do the same thing in Kira, you can either use the mesh tools, or you can move it up and down on the build plate. So if I go back, let's go to our history, and let's go this one, and we're back to normal. If you just move the model below the build plate too, in Prusa it pops back up like it's underwater. In Kira, by default, it would stay there. So if you know, if you move it and leave one there and make a copy, I should say, you're going to copy it. Let me show you. Kira, I'm going to open Kira, guys. We'll show you. But while I'm opening Kira, because it's going to take a while, are there any questions other than splitting? Because I want to show you the Kira way too, just in case. So we'll just load Kira. I don't see any more questions. Did we? I think some left, which is fine. I think we put some to sleep, which is fine. But we'll load up our Kira and show you the cut, and then let's see here. Zzz. Yeah, I think lots of people are on their way out. I think I see a couple people here. Greg's here, Andy's here, but some left. Kira's still opening, guys. I'm sorry. I apologize for Kira's slowness. Or do I? Yeah, I do. Okay. So if you guys, I'm gonna show you this, and then we'll wrap her up. Baby Yoda, Baby Yoda, do 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 do. Just kidding. I've never had speed issues with Kira. Again, it actually really only affects. It's the resolution, and it's actually the high-end video cards that really slow it down, which is weird. So if you can offload it to like a low-end video graphics driver, it's fine. But if you're using anything that's basically made to play like on the newest games, it will not be fun. So you can actually split the model into parts with the mesh tool, and then it will freeze. Baby, and it warns you, Baby Yoda couldn't be split, so it couldn't auto do it. So one of the quickest ways that I know of in Kira is make an exact copy of the model. So that's right click it, go multiply it by 1. Just waiting for that multiply. Just waiting. Old laptop for the win, right? There's something to be said about not upgrading. And like the monitor that I got Kira on right now is actually running a very low resolution. So we have 2 Baby Yodas. Oh yeah, I think Prusa Slicer is my daily driver. I only come back to Prusa when I have to actually do tree supports. So we're going to take one Baby Yoda, and we're going to rotate Baby Yoda on his head. So we want to make sure that we're right on that. Oh, it froze. Right at that 180 degrees. Come on, Baby Yoda. You can do it. Come on. Please. It's thinking about it. Yep, it's still thinking about it. It'll wake up. Trust me. It'll wake up. There it goes. So it rotated our one Baby Yoda 180 degrees. And from there, we select both of them. So let's just hover over it and make sure we get both. So I select 1, I select 2. And then all I have to do now is I'm going to move it. And I just need to know the height of my platform. And then anything. Oh, come on, Kira. Guys, I love Kira. So if I knew the size or the height of the model, which I think I do, it's over here in the edge. All I do is drag this and Kira freezes. So take the height of your model, divide it in half, and move your model in the Z direction half below the build plate. And since you have a copy of both, it's split in half and it'll print like that. That's the fastest hack for, yeah, like that's, yeah, see, so like anything below the build plate won't print now and everything above won't print. So you're guaranteed to get the half of the model you want. You can also do it where you rotate it in the horizontal instead of the vertical. Let's just hit slice and see what happens. But I'm not holding my breath because it might take a minute. So yeah.
I'll just.
No, that's fine. No, come back. Come back. Both of us. I like it. Whoa. Okay. So we're still slicing. We're almost there, guys. I'll show you what it looks like. But I know we're talking nozzles. I'm just going to throw it in at the end here. Nozzles are great. The stainless steel nozzle, however, is a little more sticky than the brass. So you're going to want to maybe bring your Z level up just a touch. So it's still smushing, but it's not so close that it's going to like push it and pull it off the build plate. So let's just, it's finished slicing. Let me show you. And boom. So this is what our render looks like. And you can see here that if I go down to layer 0, they're both on the build plate. They print up. And we finish our completed Baby Yoda. So split in half in Kira, the hacky way. So yeah, me too. There we go. There you have it.
All right. Well, I hope everyone learned something today. And feel free check out some of our tutorials online. If you have a question about something, most likely everyone else has the same question. So don't say, well, I should know that. No, don't
No,
ask.
no.
I mean, it's okay. We all start somewhere, and the splitting of the model, that was new to me. Sliding it through the build plate like that, that's a new tip to me. That's a great tip. I knew the
It's
Prusa
hacky.
one, but I didn't know the one how to do it in Kira like that. That's you learn something new every day. So
It's a fun one. And like Greg said, chances are if you ask a question, you might just see a YouTube video on our channel about it. Because if you have the question, there's 10,000 other people out there that will want to know too. So
absolutely.
you guys, it's been awesome. This is it. This is session 2, advanced 3D printing done. So
And remember,
you
these videos
take it easy.
are available. You've got the links to them, so you can rewatch them if you need
Yep.
to. If you really want to fall asleep, watch them again. But hey,
Yeah, do
I
it.
hope you learned something.
And we'll repost the links because they'll have changed tomorrow. I'll send you an email after this one's done rendering with the updated YouTube. So until we meet again, friends, see you
See
later.
you later.